following video presentation is one of a training series sponsored by the National Insulation Contractors Association. Organized in 1954, NICA represents over 500 union and merit shop contractors, distributors, suppliers, and manufacturers in the commercial and industrial insulation industry. This and other video presentations have been developed as a visual instructional partner to the NICA Insulation Craft Training Program, a self-study, competency-based training project designed to help improve the craft skills of NICA member employees. The video instruction you are about to experience, Metal Jacketing, Protection for Insulation, is made possible by the cooperation and support of Childers Products Company, a NICA associate member and leading supplier of insulation protection products. NICA thanks Childers Products Company and the other associate members of NICA who have heartily endorsed our training efforts by financially supporting this training series. Without their help, the NICA Insulation Craft Training Program would not be possible. Associate members contributing to the development of this program are credited at the end of this presentation. To perform as designed, both indoors and outdoors, insulation requires protection against weather, moisture, chemicals, and physical abuse. This protection is accomplished by the application of coatings or metal jackets to the insulation. Subject matters of insulation and coating applications are included in other learning sections of the NICA training program. In this video tape you are about to see, we'll take a look at metal jacketing, the most common form of protection. You'll become familiar with different types of metal jacketing and why they are used. We'll learn how to measure jacketing for straight piping and fittings, and then we'll cut the metal. Applying jacketing to straight piping or fittings can be an art. You'll also learn the best methods to apply roll jacketing and fitting covers. But seeing isn't the same thing as doing. Experience is the best teacher. So feel free to work right along with us, measuring, cutting, and applying your own metal.
Aluminum jacketing is the most widely used metal weather barrier for insulation. It's easily fabricated, cost-effective, and works well in moderate chemical environments. Other jacketings used to protect insulation include stainless steel, coated aluminum, coated fabrics, and plastic jacketings. To complement metal pipe jacketing, pre-manufactured fitting covers are available. Also, fitting covers are oftentimes field fabricated from roll jacketing in the field. Aluminum jacketing is available in thicknesses from 6 mil to 50 mil, in widths of 3 or 4 feet, and in lengths of 100 feet. 16 mil aluminum is most widely used because it will withstand mechanical abuse and is easily fabricated. Stainless steel jacketing is available in 10 mil and 16 mil thicknesses, in widths of 3 feet and lengths of 50 feet. Plastic jacketing are available in thicknesses ranging from 10 mil to 50 mil, widths of 4 feet and lengths determined by weight. 20 mil is the most widely used thickness. Metal jacketing may be mill finish, stucco embossed, or in a smooth 3/16" corrugation. Corrugations add rigidity to jacketing, which allows a lighter thickness to be used without sacrificing strength. All metal jacketing is installed according to specifications.
Lighter aluminum thicknesses, such as 6 mil or 10 mil, are often specified for indoor overhead insulated piping or where resistance to mechanical abuse, such as dents, scratches, and bumps, is not a factor. Medium aluminum thicknesses, such as 16 mil and 20 mil, are often specified for outdoor use and indoor areas subject to mechanical abuse. Stainless steel is often specified in areas subject to caustic or acidic exposure and when extra protection against fire is necessary.
Rolls of jacketing are shipped in cardboard cartons marked with the type, thickness, width, and length of the contents. When working with carton jacketing, be sure to always stack them on their ends with the contents markings visible on top. If different thicknesses or types of jacketings are used on the job, you'll need to separate them for easy identification when they need to be transported to the work area. Moisture barriers are normally applied to metal jacketing by the manufacturer. The most widely used moisture barrier is a laminate of polyethylene and craft paper. It's commonly referred to as polycraft moisture barrier. Liquid and plastic coatings are also used to protect against moisture. The moisture barrier provides a longer service life for the jacketing.
If the insulation gets wet, the insulation loses its ability to insulate and the jacketing may corrode. A moisture barrier between the jacketing and the insulation minimizes corrosion, even if the insulation becomes moist. When working with jacketing, you'll need to help protect that moisture barrier from abrasion, which can cause corrosion and a need to replace the jacketing. Metal jackets can be cut from rolls in the field or in the shop. It can also be pre-cut and rolled by the manufacturer to a specific pipe size and insulation thickness. Large fabrication shops in the warehouse or in the field often use automatic cutting rolling machines to handle their large volumes of jacketing at one time. Smaller jobs may not require this machinery, so the jacketing may be cut by hand. When cut in the field or shop, the cut length is determined by adding 2 or 3 inches for an overlap to the circumference of the insulation. If the diameter of the insulation is less than 12 inches, the cut jacketing should be curved by a sheet metal roller to ensure proper fit.
Metal jacketing, when applied, always has 2 seams and overlap areas, one longitudinal and one circumferential. It's applied normally with a 2 or 3 inch longitudinal overlap. For appearance or safety reasons, the longitudinal edge may be specified to be folded or hemmed. Prefabricated jacketing supplied by the manufacturer comes with a longitudinal Z-lock for secure closure. These overlaps allow for thermal movement of the piping while preventing water entry and corrosion. Metal jacketing is held against the insulation by screws, blind rivets, or strapping with seals. Strapping with seals are most often used. The metal used for fastening system is the same as the jacketing, except that stainless steel strapping with seals are specified for aluminum jacketing when diameters are large or severe wind encountered at the job site. You now know what types of jacketings are used to protect insulation, where they are used, how they are identified, and why our overlaps are always necessary. The basic fundamentals. One more fundamental. Learning how to measure jacketing needs to be learned before we can cut and apply the jacketing.
Let's set up a hypothetical situation. Let's say specifications require we insulate and jacket 120 lineal feet of 6-inch piping with 1 inch of fiberglass. The insulation must be jacketed with 16 mil corrugated aluminum with polycraft moisture barrier. A 2-inch longitudinal overlap is required for each section of jacketing, as is a 2-inch circumferential overlap. The first thing we are going to do is to see if we have a cut-to-length chart supplied by our foreman. If not, we'll need to take a look at the insulation manufacturer's outside diameter chart, commonly referred to as an OD chart, to locate a 6-inch OD by 1-inch insulation thickness. Normally, you'd think a 6-inch pipe plus 1 inch of insulation on each side would equal 8-inch OD. But the same size of the pipe insulation from the different manufacturers may have different ODs. In reality, when the charts are consulted, the OD is 8.62 inches. So if you don't refer to the chart, you might cut the jacketing too short. The circumference of a circle equals pi times the diameter. In this case, the circumference equals pi, or 3.14, times 8.62, which equals 27 inches. To that is added 2 inches for longitudinal overlap for a total circumference of 29 inches for each section of jacketing. To find out how many 29-inch sections are needed, divide the length of the insulated pipe, 120 lineal feet, by 3 since the jacketing is 3 feet in width. The answer is 40 sections before taking into account the need for a 2-inch circumferential overlap for each section. To find out how many sections are needed, including the circumferential overlap, multiply the number of sections, 40, by the amount of overlap 2 inches to determine the total number of overlap inches. The answer is 80 overlap inches necessary. Then divide by the width of the jacketing, 36 inches, to determine the number of extra sections needed. In this case, 2.2 extra sections are needed. Round off upwards for complete pieces and your answer is 3. 40 sections plus 3 sections for the circumferential overlap equals a total of 43 sections needed. Each section 29 inches by 36 inches to jacket 120 lineal feet of 6-inch pipe with 1 inch of insulation.
You can easily use this same method to figure out the needed number of size of sections or any size pipe with any thickness of insulation. If you are ordering jacketing sections from your fabrication shop, you'll need to always list the pipe size, the insulation thickness, and the length of the insulated piping unless you order specific sizes from your own calculations.